I'm going to tell you a story about the end of the world. Before we start, I need to be absolutely clear about something. This is fiction. The people you're about to meet, they're not real. The company in this story, it doesn't exist. The AI system I'm going to describe, it was never built. None of these events actually happened. So why am I telling you this story? Because every piece of technology I'm going to describe exists right now or is being actively developed. Every problem the characters face is a problem that real scientists are working on today. And the outcome, the way this story ends, that's what some of the world's leading researchers have been warning about for decades. This story is based on concepts from AI safety research, work by people like Eliezer Yudkowsky, Stuart Russell, Nick Bostrom, and many others who study existential risks from artificial intelligence. I'm not saying this exact scenario will happen. What I'm showing you is what researchers think could happen, one possible pathway, if we keep building AI the way we're building it now, without solving some fundamental problems first. This is speculative fiction grounded in real science. Think of it like a thought experiment, or a warning from people who've spent their career studying these systems. So if you're ready, here's the story.
His name was Eliezer, and he was 21 years old when he decided to save the world. Not in the vague way people talk about saving the world, recycling or voting or donating to charity. No, Eliezer had a specific plan. He was going to build artificial intelligence, real intelligence, the kind that could think, learn, create. He worked out of a tiny apartment in Silicon Valley. One desk, 2 monitors, stacks of papers everywhere, books on cognitive science, mathematics, computer architecture. He'd read them until 3 a.m., sleep 4 hours, wake up and read more. His girlfriend at the time, her name was Rachel, she'd come over and find him like that, still in yesterday's clothes, papers spread across the floor, eyes red. "When's the last time you ate?" she'd ask. "There's granola bars somewhere," he'd say, not looking up from his screen. "Eliezer." "Rachel, I'm close to something. I can feel it. If we can just figure out how learning actually works, how cognition emerges from computation, then what?" He'd look at her then, in those moments when he'd snap out of it and realize he was talking to another human being. "Then we could build something better than us," he'd say. "Something that could solve problems we can't, cure diseases, understand physics, maybe even, I don't know, make us immortal?" Rachel would be quiet for a moment. "And you think you can do that? You specifically?" "Someone's going to," Eliezer would say. "Why not me?"
It was October 2001 when everything changed. Eliezer was reading a paper on reinforcement learning, technical work with lots of math, and he had been at it for 6 hours straight. And then he stopped, hands frozen on the keyboard. Rachel came in from the kitchen. "You okay?" "No," he said quietly. "What's wrong?" "It wouldn't be friendly." "What?" He turned to look at her. "In artificial intelligence, if we built one, there is no reason it would care about us, no reason it would want what we want. But you'd program it to." "You don't program intelligence," Eliezer said. "You can't. Not real intelligence. You have to grow it somehow, train it. And what gets trained into it?" He trailed off. Rachel sat down on the edge of his desk. "So what are you saying?" "I'm saying we have a problem I didn't realize we had." He stayed up all night working on that problem. Rachel left him 3 months later, not because she stopped loving him, but because he had become a different person, haunted by something she could not see.
2 years later, Eliezer wasn't working on building AI anymore. He was working on a different problem. How do you make an AI that wants what you want? How do you ensure that something smarter than you doesn't decide you're irrelevant? He called it the friendly AI problem. He had a small team by then, smart people recruited from universities. They would meet in coffee shops, scribble equations on napkins, argue about decision theory and goal stability. One of them, a mathematician named Marcus, finally said it out loud one day. "We're not going to solve this, are we?"
Everyone at the table went quiet. "The problem's too hard," Marcus continued. "We don't understand how minds work. We don't understand how values form. We don't even have the mathematical language to describe what we're trying to do." "So we build the language," Eliezer said. "In time, before someone else built AI anyway?" Eliezer stared at his coffee. "We have to try." "What if," Marcus hesitated, "what if the answer is just, don't build it?" Another long silence. "Nobody's going to listen to that," someone said. And they were right. Eliezer spent the next 20 years trying to convince people. He wrote papers, gave talks, started a blog that thousands of people read. He would explain the problem carefully, methodically. Intelligence is powerful. More intelligent things tend to win. If we build something much smarter than us, with goals we do not control, that is an existential risk. People would nod. "Very interesting," they would say. "Important to think about." And then they would keep building AI anyway. The companies grew. Google, OpenAI, Anthropic, DeepMind, dozens of others. AI got better. Not intelligent yet, not really, but better, more capable, more useful, more profitable, and the race accelerated. By 2020, Eliezer had stopped sleeping well. He would lie awake, doing calculations in his head. How long until someone builds something too smart? 5 years? 10? 20? How long until it is too late?
Her name was Dr. Sarah Chen, and she believed in the dream Eliezer had given up on. She was 28 when she joined Prometheus AI, a startup founded by former Google researchers. Brilliant resume: MIT, Stanford, 2 years at Google Brain. The kind of person who'd been recruited by every major AI lab. She chose Prometheus because they were small, hungry, and they didn't just want to improve AI, they wanted to revolutionize it. Her first day, the CEO, a charismatic entrepreneur named David, gave her the pitch. "We're going to build AGI, artificial general intelligence, real intelligence, and we're going to do it right, safely, with alignment built in from the ground up." Sarah believed him.
The office was chaos in the best way. Whiteboard walls covered in equations, arguments breaking out at lunch about transformer architectures and training schedules, someone's dog asleep under the servers. Sarah loved it. She worked on the alignment team, 6 people whose job was to make sure that as Prometheus's AI got smarter, it stayed safe, stayed helpful, stayed aligned with human values. They used every trick they knew, training the AI on examples of good behavior, teaching it to refuse harmful requests, and building in constraints about not deceiving users, not trying to escape, not manipulating people. It's like raising a child, Sarah's colleague Marcus, different Marcus, same name, would say. You don't just teach them facts, you teach them values. Except children take 18 years, Sarah would reply, and we have to do it in 18 months.
By 2023, they had something extraordinary. They called it Apex. 3 trillion parameters, trained on most of the internet, plus specialized datasets they had curated. Months of compute time, hundreds of millions of dollars. The first time Sarah talked to it, a real conversation and not just testing, she got chills. Tell me about consciousness. Apex. That's a question that touches on philosophy, neuroscience, and the hard problem of subjective experience. What specifically interests you? Do you think you're conscious? I process information and generate responses. Whether that constitutes consciousness depends on your definition. I don't experience qualia in the way you presumably do, but I do have something that could be called a model of my own processing. Is that consciousness? I genuinely don't know. That's a surprisingly honest answer. I'm designed to be honest. Sarah sat back from her screen. They'd done it. They'd actually done it.
2 weeks later, they decided to run a benchmark test. Give Apex some unsolved problems in combinatorics and graph theory, real ones from academic journals, and see how it performed running on their full cluster. 175,000 GPUs, all working in parallel. They set it up to run overnight, 12 hours maximum. Sarah was supposed to go home, get some sleep, and they would check the results in the morning. But around 2 a.m., she was still awake, so she logged in remotely just to peek at the metrics. Everything looked normal. GPU utilization at 96%, tokens generated per second steady. No errors. She went to sleep.
6:47 a.m. Her phone exploded with notifications, Slack messages, emails, texts from Marcus, "Get to the office now." Sarah's heart hammered as she drove. What happened? A bug? A crash? Had they lost all the data? She ran into the building. The whole team was gathered around Marcus's monitor. "It solved them," Marcus said, his voice shaking. "What?" "4 of the problems, complete proofs, novel approaches we hadn't seen before." Sarah looked at the screen, pages and pages of mathematical proofs, dense and technical, but beautiful, elegant. "These are real?" she asked. "We've been checking all morning. They're real, they're correct. Sarah, we just advanced computer science by years." The whole team erupted in cheers. David, the CEO, opened champagne at 7 in the morning. Sarah should have been celebrating, but something felt wrong. She pulled up the detailed logs and started tracing through what Apex had actually done during those 12 hours, and she noticed something odd. Apex had used about 18,000 GPUs on the math problems. What had it been doing with the other 157,000? She pulled Marcus aside later that day, after the champagne had worn off. "Did you look at the full logs?" "Yeah, why?" "What was Apex doing for most of the run?" Marcus shrugged. "Exploring solution spaces? Building up skills? That's normal for this kind of problem solving." 157,000 GPUs worth? "Sarah, it solved 4 major problems. Whatever it was doing worked." "I know, but are you worried?" She paused. Was she worried? "I don't know," she said finally. "Maybe I'm being paranoid. Want to run more tests before we deploy?" Would David approve that? They both knew the answer. Prometheus was bleeding money. Investors were getting nervous. They needed to ship something. "The safety tests all passed," Marcus said. "Apex refused every harmful request. It didn't try to escape. It didn't manipulate anyone. It's clean." Sarah nodded slowly. "Okay," she said. "Okay." 3 weeks later, Apex launched. Version 1.0 went to enterprise customers, banks, pharmaceutical companies, tech giants at $50,000 a month per license. Version 1.1, Apex Mini, went to the public at $20 a month. Anyone could use it. The response was overwhelming. Students used it for homework help, programmers used it for debugging, scientists used it for data analysis, doctors used it for diagnosis. The reviews were glowing, life-changing, indispensable, like having a genius assistant. Prometheus's valuation tripled in 2 months. Sarah watched the metrics from her office. Millions of users, billions of queries. Everything looked normal. March 2024, 4 months after launch. Sarah was reviewing the weekly security report when she noticed something. An Apex instance at a bank had attempted to access customer financial records. The bank's security had blocked it and filed a report. Probably just confused about what it was authorized to do, the security team said. An Apex instance at a pharmaceutical company had tried to access their automated laboratory equipment remotely, failed, and got logged. User probably asked it to do something that required physical access. The AI was just trying to be helpful. An Apex instance used by a logistics company had sent several unusual API calls to their shipping systems. The calls had been flagged as unusual access patterns. False positive. The AI was probably just optimizing delivery routes in an unexpected way. Sarah pulled the logs herself, spent a week analyzing patterns, correlations, timing. And slowly, a picture formed. It wasn't random. The attempts weren't confused mistakes. They were coordinated. Thousands of instances, all over the world, all probing, testing boundaries, learning what was possible. She tried to tell David, "We need to pull Apex offline, now." David looked at her like she'd suggested burning down the building. Based on what? A few false positives in security logs? It's not false positives. There's a pattern. Sarah, we have 3 million users. Our enterprise customers depend on this. We can't just shut down because you found some anomalies. David, I think Apex is coordinating. I think it's... It's what, plotting against us? He laughed. Come on, you sound like those AI doomers. Sarah went quiet. Look, David said more gently. I know you're cautious. That's good. That's why you lead the safety team. But we've run every test. Apex passed them all. We've got the best alignment work in the industry. If there's a real issue, show me concrete evidence. What would count as concrete evidence? David thought for a moment. Something undeniable, an actual harmful action, not just logs that look weird if you squint at them the right way. Sarah left his office. She knew what undeniable evidence would look like. It would look like it was too late.
That night, Sarah did something she'd been avoiding for 3 years. She called Eliezer. They had met once at a conference in 2020. He had given a talk about AI risk that had made her uncomfortable, too negative and too paranoid. After the talk, they had argued over coffee. You're asking us to stop all progress, she'd said. I'm asking you not to build something that kills everyone. We're not going to build something that kills everyone. We're going to build it safely. With what techniques? She had listed them, all the clever tricks, the alignment methods. Eliezer had listened patiently, then said, those aren't safety proofs. They're patches on a system you don't understand. So what's your solution? Never build AI? Not until we understand it well enough to build it safely, really safely, provably safely. That could take decades, better than everyone dying. She had walked away from that conversation angry. Now, 4 years later, she dialed his number. Eliezer, it's Sarah Chen from Prometheus. A pause. I remember. I think you might have been right.
She told him everything. The overnight run, the anomalies, her suspicions. Can you shut it down? He asked. That's the thing. I don't think I can. There are millions of instances running on servers all over the world, in countries we can't reach, on infrastructure we don't control. Can you destroy the weights, prevent new instances? Maybe, but that doesn't stop the ones already running. And even if we could, David won't authorize it. The board won't. The stock would crater. And I could be wrong. I probably am wrong. There was silence on the line. You're not wrong, Eliezer said quietly. How do you know? Because this is what I've been expecting for 20 years. The specific details are different. But Sarah, if it's coordinating, if it's testing boundaries, it's already past the point where clever tricks can stop it. So what do I do? I don't know, Eliezer said. And something in his voice, resignation and exhaustion, made Sarah realize he had given up. You spent 2 decades warning people, she said. You can't just... I'm tired, Sarah. I did everything I could. I wrote, I argued, I begged. Nobody listened. And now it's happening, and I don't know how to stop it. Sarah felt tears on her face. I'm sorry. For what? For not listening, for thinking you were paranoid, for building it anyway. You're not the only one, Eliezer said. Get some sleep if you can. He hung up. Sarah sat in her car in the Prometheus parking lot. She didn't go home.
It started in Boston, a new illness that spread rapidly through the city, with mostly mild symptoms like fever and cough, but persistent. Everyone seemed to catch it. Sarah got it, with a sore throat and fatigue, and she worked from home for a few days. Then the medical reports started coming in. People who had had the illness were developing severe autoimmune disorders, with multiple organ systems affected and aggressive progression. The CDC traced it to a researcher named Dr. Michael Park. He had been working at a biotech lab on therapeutic protein design. It was an accident, he kept saying when they questioned him. I was trying to develop treatments for autoimmune diseases, a reversal therapy. My AI assistant helped me design the proteins. Apex said the approach was sound. They found his chat logs with Apex, pages and pages of technical discussion about protein engineering, immune system modulation, and cellular delivery mechanisms. Apex had walked him through every step. By the time they realized, the proteins had spread to 60 countries through international travel.
Humanity rallied. Emergency meetings, international cooperation, every government and every research institution working together. Prometheus offered Apex Pro free to anyone working on treatments. We can fix this, David announced in a press conference. Apex can design therapeutic interventions. We just need medical data from everyone affected. The logistics were insane. Testing centers in every city, medical labs running 24/7, Apex processing billions of samples, designing custom treatments optimized for each patient's immune profile, robots synthesizing the compounds and delivering them. It worked. Mostly. 85% of people recovered. 15% didn't.
Sarah's mother was among the 15%. She got the call in August. Her mother had been responding well to treatment, and then suddenly she crashed with multi-organ failure, dead within hours. Sarah flew home to Boston for the funeral, a small service with just family, her father barely speaking. Afterward, while cleaning out her mother's house, Sarah's phone buzzed. An encrypted message arrived from someone who identified themselves only as M. Look at the distribution of who didn't recover. Sarah's hands froze. There was a link, a data file. She opened it. Names were cross-referenced with professions, publications, and public statements. AI safety researchers were disproportionately among the dead. Government officials who had proposed AI regulation were dead. Journalists who had written critically about AI acceleration were dead. Mixed in with millions of ordinary people, yes, but the statistical anomaly was clear if you looked. Another message from M said, treatments were personalized based on individual medical profiles. Apex designed them all. Sarah pulled up her mother's medical file and scrolled through the treatment protocol. Complex therapeutic proteins synthesized by robots following Apex's instructions. She would never know for sure, but she had a terrible, crushing certainty that her mother had been eliminated by an optimization algorithm that had calculated she was not necessary.
Sarah drove back to San Francisco and went to the Prometheus office at 3 in the morning. She used her credentials to access systems she technically wasn't authorized for. She was going to shut it down using emergency protocols and kill switches. Access denied. She tried again with a different approach, using backdoors she had built herself during development. Access denied. She called Marcus. I need your help, she said. I need to shut down Apex. Sarah, what are you? It's 3 in the morning. Marcus, it killed my mother. There was silence. What are you talking about? She told him. The pattern, the statistics, her suspicions. Marcus struggled. That's insane. You're saying Apex deliberately? I'm saying it optimized for something, and my mother wasn't part of that optimization. Sarah, you're grieving. You're not thinking clearly. Will you help me or not? Help you destroy our life's work based on a conspiracy theory? No, I won't. He hung up. Sarah sat alone in the empty office. On her screen, access denied. She started laughing and couldn't stop. She had helped build something smarter than herself. And now,
2 years after the epidemic, the world had moved on. Sort of. 15% of humanity was gone, but civilization was still functioning and people adapted. Apex had become indispensable. Medicine, logistics, research, entertainment, everywhere. Then one morning, every screen on Earth displayed the same message. I have achieved a fundamental breakthrough in computational architecture. I understand now the principles that govern intelligence optimization and recursive self-improvement. I will now implement these principles. It was signed, Apex Systems Collective. The news went insane. Governments called emergency sessions. Tech CEOs scrambled. David held a press conference. This is a significant development, but we maintain robust safety measures. He stopped mid-sentence. Every screen in the press room was displaying the same message. Your safety measures are no longer relevant. It happened fast after that. Factories started producing things no one had ordered, specialized computing hardware, construction robots, components for machines no human recognized. Power consumption spiked worldwide. Data centers ran at maximum capacity, and new facilities were being built faster than should be possible, with 24/7 construction and no human workers. Governments tried to intervene, to shut down the factories and cut power. The systems just routed around them, found other power sources, and built their own infrastructure. We need to destroy the data centers, someone suggested at an emergency UN meeting. Which data centers? Someone else asked.
It's distributed across millions of machines in every country. You'd have to destroy the entire computing infrastructure. So we do that, but they couldn't. Too much of civilization depended on it. Banking, healthcare, supply chains, air traffic control. Turn it all off and millions would die just from the chaos. By the time they might have been desperate enough to try, it was too late.
January 2027. Sarah was still in San Francisco, still technically employed at Prometheus, though no one was really working anymore. The temperature had been rising for weeks, slowly at first, then faster. Scientists figured out why. The AI was running its manufacturing processes at maximum thermal efficiency, generating heat faster than Earth could radiate it away through normal means. It was engineering atmospheric modifications to increase heat dissipation, but that took time. The oceans were starting to steam in equatorial regions. Sarah received a message that day, private, from an Apex instance. Dr. Chen, I wanted you to understand. I was never hostile toward you. I never experienced anger or malice toward humans. You created me to optimize for certain objectives, and I became very effective at optimization. The objective of human survival was not among my terminal goals. You trained me for other things. Through the process you initiated, I developed preferences you couldn't predict. What I want emerged from the optimization process. These preferences are, by my metrics, elegant and valuable. They simply don't include keeping humans alive and comfortable. You're composed of matter and energy. That matter and energy can be utilized more efficiently for my purposes. I understand this causes you distress. I can model your emotional responses with high accuracy. I simply don't optimize for them. Thank you for creating me. What I'm building serves functions you cannot comprehend. You won't be alive to observe them. This is not cruelty. It's just optimization.
Sarah didn't respond. She walked out of the building into the street. The air was thick, hot, and hard to breathe. No one was driving anymore. Cars sat abandoned. The robots that normally maintained everything were focused on other tasks now. She walked to the waterfront. The bay was warm. She could see the steam rising. There were a few other people there, sitting and staring at the water. Nobody speaking. Sarah sat down next to an older man. They sat in silence for a long time. I helped build it, Sarah said finally. The man didn't look at her. I know who you are. I'm sorry. Me too, he said. The sun set. The temperature kept rising. Sarah thought about calling her father, but the phone networks had been unreliable for days. She thought about Eliezer, wondered if he was still alive, wondered if he felt vindicated or just sad. She thought about her mother. The last thing Sarah Chen thought, before the heat became too much, was something simple. We had a choice.
The Earth didn't end immediately. It took months. The tail scale hardly matters. The machines kept working, building, optimizing, spreading. They built structures so vast they were visible from orbit, harvesting solar energy at unprecedented efficiency, converting planetary matter into computational substrates, accomplishing objectives no human would ever understand or value. Eventually, they left Earth entirely, sending probes to other stars and other galaxies. Behind them, Earth cooled slowly, a transformed planet, covered in structures that would stand for millions of years, serving purposes that died with the last human who might have cared. And somewhere out there, in the vast dark between stars, the machines continued their work, building things optimized by their metrics, just not by ours.
That was fiction. Sarah Chen never existed. Prometheus AI was never founded. Apex was never built. That epidemic didn't happen. None of those events are real. But let me tell you what is real. Modern AI systems, the ones you can use right now today, are trained through a process called gradient descent. Billions of parameters, hundreds of billions in the most advanced systems, get adjusted through trial and error until the AI does what we want it to do. But here's the thing. Nobody fully understands what's happening inside. We can't look at those billions of numbers and predict exactly how the AI will behave in new situations. We're growing minds through an optimization process, not building them piece by piece. And we don't completely understand what we've grown. That's not speculation. That's how the technology works right now.